Okay, hopefully you guys did all right on your lesson 12.1 yesterday, and that you were doing good on it. Today's lesson is 12.2, congruent polygons. But before we get going on it, there's two questions that we're going to review, and then just review what we've done up to this point. These two questions, this question deals with similar shapes. Two shapes are similar if they have the same size, but one shape's obviously bigger than the other. That makes them similar, not congruent. Notice today's lesson is called congruent polygons. So these are not congruent, they are similar. So I want to review with you how to solve for this problem. When we're doing similar shapes, it never matters what you pick first, it only matters what you pick next. It says using proportions. The moment we hear the word proportion, we always set up a fraction equals a fraction. So we're going to set that up now that we've got 4 items and we've got 4 spots. So we just have to make sure we match things up correctly. So I'm going to match up X with 18 because those sides are similar. And I'm going to match up this 150 with the with 75 because they are similar. And now it doesn't matter what you pick first, it only matters what you pick next. So I'm going to pick X, so I'm going to put 18 under it. Now, because I chose X and it's on top, I go back up to that shape to get the next number of 75 over 150. And now it's just a matter of cross multiplying to solve it. So we'll cross multiply, and we're going to get 150x equals 18 times 75 is 1350. We'll then divide by 150, and we get x equals 9. And so our answer on that first problem is 9. So again, over here, similar. We have similar shapes because they told us they were similar. Use proportions, so we'll say a fraction equals a fraction. It doesn't matter what you pick first, it only matters what you pick next. So the 115 and the 5 match up, and the X and the 3 match up. You just have to match things up that go together. And then it doesn't matter what you pick first, it only matters what you pick next. So this time, instead of picking X, I'm going to pick 115. So that's over 5. I chose 115 from the bigger picture, so I have to have that on top. That's X over 3. So I'm going to go cross multiply. 115 times 3 is 345 equals 5x. Divide by 5. And x will equal 69. And that's how we review doing similar shapes. Okay? So we'll go to our next slide. This is a review problem as well. I'm not going to graph it, but I'm just going to walk you through how you would do this, and then you could graph the final answer. We're going to take this segment. So graph the segment XY with endpoints. So here's the points where they are, and it's going to be a graphed image after these two transformations. So I'm going to walk you through how to do this transformation, a slide transformation. Remember, this is slide, and this is rotates. So we'll do the translation first. So x of -2 and 0, and basically I'm going to do nothing to the x because it says do nothing. Take the ordered pair, do nothing to x, leave it the same, but subtract 3 from the y. So my new point will be x asterisk, and it will be -2, -3. The other point, y, is 5 and -6. So y asterisk will be 5, -9. Now they want us to rotate it 90 degrees counterclockwise. If you remember, counterclockwise is left. So if you remember, we switch the 2 ordered pairs. So we switch the 2 numbers, and then we change our new x because that's the way you're turning it. So x double asterisk will be -3, -2. That's switched. And then I change the sign. So there's one answer. and then y double asterisk. We'll switch the two, so -9, 5, and then again, we switch the sign. And that would be the answer for the final result on that transformation. If you remember, we did that in chapter 11, okay? All right, let's talk about rigid motion for a minute, reviewing what we did in chapter 11 for just a second. Now, rigid motion only can be done with 3 different transformations. Translation, which means slide. Reflection means flip. And rotation means turn. Now, those 3 are the ones that you can have rigid motion with. This one is not rigid motion. Okay, not rigid motion. It is a transformation, but it's not rigid motion. It's actually what we just got done doing with those similar problems at the very beginning. So dilations are used for similar shapes. So the shapes end up being similar because one shape's bigger than the other, but it is not rigid motion. These 3 right there are rigid motion. Okay, because they maintain, the main reason is they maintain their size and shape. Okay, dilations do not maintain their size and shape, therefore they're not rigid motion. All right, that brings us to our lesson. We're going to start talking about congruent shapes. Okay, there's 2 things that make shapes congruent. The very first thing is all their angles have to be the same. So in other words, all the angles have to be congruent. Okay, remember congruent means that symbol. The second thing, all sides must be the same. That means congruent. So 2 shapes are congruent if and only if all their angles are exactly the same and all of their sides are congruent or the same. Okay, so they want us to write a congruent statement, so I'm going to teach how to do that. It never matters what you pick first, it will only matter what you pick next. So we're going to pick this shape, and we're just going to say JKL. So triangle JKL, and it's going to be congruent to triangle. Now let's go match it up. This is how you can tell what goes together. Ready? J. So find J, look at the markings. It has 2 marks on it, so find 2 marks on the other shape. T. K. K has 3 markings to it. Find the shape that, or the part that has 3 markings to it. That's S. And L. L has 1 marking to it. R has 1 marking to it. And that is a congruent statement. And that tells you all the parts that are exactly the same. So for instance, J matches T, K matches S, L matches R. Now here's the segments that match each other. JK segment matches TS segment. KL segment matches SR segment. JL segment matches TR segment. As you can see, the markings show that. Okay? That's our main part of our lesson. That's what we're basically proving everything off of today. Okay? So let's learn how we can use these statements, this congruent statement. That is a congruent statement for a 4-sided shape. Notice there's not a symbol in front of it. As soon as you go to 4-sided shapes, they just have the letters. And we're going to use this to solve for x. So find out whatever part has x to it. Now there's 2 parts that have x to it. One is a side and one is an angle. Just let me make sure that you understand something. If you are finding anything that has to do with a side, then you have to use sides. If you are finding anything that has to do with angles, you have to use angles. So we have x as a side, so I'll use a side to match it. We have y as an angle, and x is with it, but we've got to find x first, okay? And we'll use an angle to go find our other angle. So we're going to set that up. All right, well, let's find out what matches this X. QR. So find QR up in the picture. QR is right here. So we need to find the two letters that match it. It's FG. So QR matches FG, therefore they are congruent, therefore they are equal. So this piece matches this piece. So then I can say 2x minus 4 equals 12. And now we've got an equation that we can just solve for x. We'll add 4, and 2x equals 16, and x equals 8. Well, once we have that 8, now we can help ourselves by saying, all right, we're going to substitute the 8 where x is and say 6y plus 8. That's the new part for where x, for q. Angle q. So angle q is right up here. Angle q matches angle f. So angle q matches angle f, and angle f is 68, so we'll set those two equal to each other. So 6y plus 8 equals 68. And now, again, we have an equation with only one variable in it now because we did substitution, and we can solve for our y value. So we'll subtract 8. 6y equals 60, and divide by 6, and y equals 10. And that is a way you can use equations, or you can use the congruent shapes to help us solve for equations or solve for missing variables, okay? All right, you're going to divide a wall into, let's see how this will help us. You're going to divide a wall into orange and blue. So obviously this is more of a yellow color, but it's orange and blue. And these sections along the line, JK. Will the sections of the walls be the same size and the same shape? Well, let's decide. Based on the markings. Well, we said that all the sides had to be congruent and all the angles have to be congruent as well. So right now I see all the sides are congruent. So this side matches that side, this piece matches this one, this side matches this one. That's not enough. You have to make sure that the angles match up too. Well, let's remind ourselves what the shape was originally. The shape originally is a rectangle. Now we know rectangles have two parallel sides to them. Opposite sides are parallel. Well, the moment we see that that opposite side is parallel to this side, then that line JK becomes the transversal. Therefore, there are congruent angles. This angle would match this angle. So angle 2 is congruent to angle 3. And angle 4, I'm going to put 2 marks with it, is congruent to angle 1. Therefore, now all the angles match up. We've got this angle matches this one. This angle matches this one. We've got 90s in the other spots. Then all the sides are. So yes, they are congruent. I'll just write it better. Because of congruent angles and sides. So that is proving that those are going to be congruent. All right, we're getting there. All right, we're going to use this shape again to solve for missing pieces, okay? They're saying in the diagram that this shape is congruent to that one, so the statement itself is going to help us set this up. We want to find our x value. It says identify all the congruent parts first. So I'm going to start naming all the parts. Let's name all the angles. So angle A is congruent to what? It would be angle C. Angle B is congruent to angle D. Angle G is congruent to angle E. And angle H is congruent to angle F. That's a congruent statement, or the corresponding parts that are congruent from the statement. Now we'll name the sides. AB, and you have to have the line above it, is congruent to CD. BG is congruent to DE. Just match them up. GH is congruent to EF. And here's the one that gets kids sometimes. It's the first one and the last one. So AH is congruent to CF. And that one sometimes gets kids, but you should be okay. That's how you do a congruent statement of all the parts. Now let's go ahead and go find X. Well, watch what we're gonna do. H, up here, we know it matches up with F, but it's right here, H and F. So H has our X value in it. We're gonna match it up with F. F has 105, so we'll just set them equal to each other. So 4X plus 5 equals 105. Subtract the 5, because it's saying to add here. So 4X equals 100. Divide by 4, and your X value is 25. Any questions on that? Okay. In the diagram at the left, let's show that triangle PTS is congruent to triangle RTQ. Okay, well, we can't prove that unless we have all the information we need. Well, we need to have all the angles and we need to have all the sides. Well, the sides are all marked right now, so now we have to be able to mark the angles. Well, you can't just mark angles for no reason. You have to have a reason why you can mark them. So I'm going to mark this angle and this angle because they are vertical. When vertical angles happen by two lines crossing, they are the same. They are congruent, so that's true. Then over here we have a parallel line and a parallel line. Anytime you have two parallel lines cutting the two parallel lines by a transversal, then you get alternate interior angles. So this angle and this angle would match. They're alternate interior, and then this angle down here would match this one up here. So yes, they are congruent because of all the parts. Sides and angles. All the parts are congruent because they are congruent by the sides and angles. Now remember, it's because of parallel lines cut by a transversal. Okay? We have alternate interior angles congruent. All right, let's go to this one. Here's some properties that are going to help you. Reflexive property, we've talked about that, where you can just see the same thing in the mirror, you get the exact same thing back. Symmetric is when you take it and you can flip it. So it's said this way, triangle ABC is congruent to DEF. Well, they're going to flip it around and say DEF is congruent to ABC. It's almost like they flip it and watch what it lands on. Anytime you can get something to land on something else, they call it symmetric. Okay? The transitive property is a little bit different. Watch this. The transitive property has to have something join it. So triangle ABC is congruent to triangle DEF. Then they say DEF is congruent to JKL. So do you see that DEF is joining these two? So DEF is part of that one and it's part of this one. So basically we can drop the DEF and we can put ABC with JKL. That's called the transitive property. Those are different properties that will help you throughout some of the lessons. Okay? This lesson, this part, this is the third angle theorem. It's basically this. We know that all triangles add up to 180. So if I have two angles of one triangle and they match two angles of another triangle, they're saying then the third angle has to be the same, and that's true. So every time that you ever have two triangles and they have two angles that match each other, then the third angle would have to match each other too. And that's a rule that you can call the third angle theorem. All right, we're almost there. All right, we're going to find angle, the measure of angle BDC. So if you're looking at this picture, we've got to come up with how we're going to find angle BDC. BDC, that's this entire angle down here. Well, you cannot find this entire angle here until you have that angle up here. If we have this angle right here, we could find it because then we could have that one and we could subtract it from these two and get the entire angle. So we're going to talk about a couple things. I know that this triangle on the bottom is isosceles because I have two congruent angles. So if I have two congruent angles, then I have two congruent sides. Well, if that's the case, then that's 30 and 30, that adds up to 60. Well, 180 minus 60 is 120. So if that angle is 120, this is a straight line going from here to here. So then this angle has to be 60. And if that angle is 60, and we know that one angle mark is 45, then this one's 45. Well, then I can go 60 plus 45 minus 180 will be this angle right here. $75 degrees. Well, they asked for the measure of angle BDC. That's the entire thing from here to here. So all I'll have to do now is add 75 and 30, which is 105. And that's how you find it. Okay? So we took some of the information from previous lessons and used it to decipher and solve this one. Okay? All right. It says use the information of the figure to prove that these two are congruent. Well, we'll prove it by doing this. All right, I'm going to walk you through a couple things we just talked about. All right. The two angles are congruent to the two angles on this picture. If I were to pull those pictures apart, two angles on this triangle match two angles on that triangle. Therefore, by the third triangle theorem, the third angle theorem, this angle right here would match this angle right here. So that's true. And now I'm telling you I'm going to pull it apart because AC is reflexive to AC. Therefore, 1, 2, 3, that side would match the same side for the other triangle. So 1, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 1. And then obviously we have all the angles marked. And those two pictures are congruent, so yes, they are. And we used reflexive property and the third angle theorem property to solve it. Okay? And our last one. All right. Find the measure of angle DCN. DCN, so it's this angle right here. Well, we're going to figure that out by a couple different items. Well, we know that this one's 68 and has one mark, so this one has to be 68. Well, we can find this one right here by two angles add up to a certain amount, subtracting it from 180. So I'll subtract 180, 75, and minus 68, and I get 37. So this angle is 37 by vertical angles. This one's 37. And if I already have two angles that match two angles over here, then guess what? This one has to match the 75. That's the one I wanted. DCN, angle DCN equals 75. What additional information is needed to conclude that these two triangles are congruent? Well, we have the angles right now, no problem. But what we don't have are the sides. So we would have to prove that side DN would need to be congruent to SN, and we would need to prove that DC is congruent to SR. Those other two pieces. And I'll put the markings on them. 1, 2, 1, 2, and then 1, 2, 3, 1, 2, 3. That's what would have to be the additional information to prove that those are congruent. Okay? That's the lesson. Hopefully that'll help you get your assignment done. And we'll talk to you again for Friday's lesson.